Good evening, guys. Good evening, guys. Good evening, all of you. And we have some interesting problems on our plate today, and I will tell you one of such problems. Okay, so we will do this. So first step is that we will define something called like distance between two discrete random variables. Okay, so our aim is to define something called distance between two discrete random variables. Okay, I will do it via problem solving because it's not in syllabus, so I cannot really do these things. People will tell me that you're not going by syllabus, so I'm just doing something interesting. That's why this problem solving lecture. So our agenda is distance between two random variables, two probability distributions, distance between two probability distributions and we will use that to find distances of various we will use examples to understand that, and if you have time after that we will show something interesting, okay, that you already know, but in a mathematical framework. And on our regular classes on Monday and stuff, I will show the simulation and stuff to make it much more interesting. Okay, so let's do it. Okay, let's do this. Ladies, I'm really excited for this, and some people have some doubts. Oh, I'm so sorry. I was not speaking. Yeah. So the idea is that we will be understanding distances between two discrete random variables like probability distributions, and we'll see some examples over there. And in terms of examples, we'll use our examples to understand certain really interesting things. Okay, and we'll see what those interesting things are. So let's get started, guys. Let's get started. So first, say P1. So let's first revise. I'm just revising every day because it's a really important concept. Let's revise discrete distributions, discrete random variables. So it's a function from the discrete sample, like sample space, to x1, x2, xn. Okay, not xn, say two countable numbers such that with corresponding probabilities p1, p2, okay. P infinity, say, such that summation of pi is equal to 1. I to infinity is equal to 1. And
sir,
yeah, tell me.
we were discussing about some St. Petersburg paradox.
Yeah, that was that ended right last day, Nasir.
Oh, last day.
I mean last Thursday.
Okay.
And if
Sorry.
you have any doubts, we will again discuss that on Monday class. Okay.
Okay.
Or maybe you can ask us in the one-on-one group to us. I will discuss it with you. Okay.
Okay.
Yeah,
Sir,
just let me know. Okay, so now yeah, this is the idea, and this is the basic discrete definition, discrete thing, and the example that we have defined something called Bernoulli process. Bernoulli process. Out of that, we got something two interesting ideas. Did I discuss geometric, guys? Did I discuss geometric, guys?
No, sir.
Did I discuss binomial?
Actually, sir, we just discussed the Bernoulli one.
Okay, so let's discuss the binomial one first. So binomial one is really easy. Okay, let's discuss Okay, let's discuss the first distance, and then I will go to binomial. Okay, and okay, so this is the basic idea that if P1 and P2 are two probability distributions, okay, that means you have a set of this. What set? You have a set of x1, x2, this with the corresponding P1, P2, dots, and we have another the same set of outcomes. Okay, P1, P2 are some same set of outcomes, that is x1, x2, with P1 dash, P2 dash, okay, such that summation of pi is equal to 1, and here we summation of pi dash is equal to 1. So what we are going to understand from here, so we know this idea that you must be knowing central limit theorem, some idea about this, that you know binomial converges to Poisson. Okay, binomial converges to Poisson. So we have this basic notion, right? So what we do? So therefore, this idea of convergence, we can do it in some other sense, that the distance between two distributions are decreasing day by day. Step by step. Okay. So similarly, we are understanding distance between two distributions on the same set of random variables. Okay. So we can understand that. And you may say that, okay, what? How can I do it for Bernoulli? How can I do it for Bernoulli? That the 1 0 here, what will I do for the other random numbers? You can put it 0. PIs are all 0. Okay, you can put it 0. So to make it for the entire set of infinite like numbers, the outcomes it can take. Okay, this is a basic definition. So we are P1 and P2 are two discrete random variables with this on the same set of outcomes with certain probabilities. Our aim is to find a distance between this. Tell that, okay, these two probability distributions are closer than that set of that two set of probability distributions. This will have an immense application understanding about that when two probability distributions are really close to each other. Okay, are they conveying the same idea or not? So let's understand. Let's define that. Okay, let's define that and see what comes up. So how we define that? We can define it in various ways. Okay. Like this. Let's say distance of two probability distributions P1 and P2 okay, is defined as this. Supremum, that is the maximum over A are evens, okay? A are evens. P1A minus P2A. This is very hard to understand. Like we are taking all the events and we are seeing where for which event it is really the biggest. Okay, that makes sense. So what I will do is that show that you have to first show that this distance is actually summation over n in the sample space. Okay, the outcome space. Let's take on this set 0 1 2 this set only. In this case, it's summation of that P1n minus P2n whole by 2. So this exercise, this is an exercise, okay? I will not discuss it later. It's a bit lengthier proof. Okay, so I will not discuss this today. It will take a lot of time, but the essence of the discussion will be not be validated. So let's assume this is true. So it's a homework. Show that this is actually equal to this. A is a set of all elements, and we are seeing the probability distribution between this. So yeah, it's very interesting that it's summation. A is just here's discrete subsets of this set of numbers 0 1 2. Okay, so make A are discrete subsets of this numbers and taking the sum of all of them. So in some sense it's subtraction of that. So it's a very easy, not a very hard exercise. It will just take some time. Okay, maybe you can do it for 0 1 2 and then you can add it to like do it generalized for larger numbers. So you can do this as homework, and if you can't do it, remember remind me on Monday. I will discuss this. Okay, guys. So make this, assume this. So assume that the distance between this is this.
Sir, but what does distance between two probability distributions like mean?
Yeah, so distance between two probability distributions mean that. So have you heard of this? That binomial is going towards Poisson, right?
Yeah.
Or it's if you take average of random variables, it will go towards normal.
Yes.
So this idea that two random variables are converging, that means that it's essentially the idea that how two functions are close to each other. For example, let's say it's also going to be used. Actually, this statistic is used in testing. Okay, a hypothesis testing. I will tell you what is the understanding behind it. So let's say when we say, let's say you have a function over here. Okay, and you have another function, let's say. And you have another function, let's say. Let's take this. You tell me which one is closer to the white one. Tell me which one is closer to the white one.
The blue function.
The blue function. So how do you define it? That's the idea. How to define that means there's an innate understanding of distance, so you can understand it, right, Mihika?
Yeah.
So you have to define it mathematically. Okay. That how whether it's the white function actually very close to the blue function than the yellow function. How do you define it?
It's like for some fixed x, if I check fx for all these three functions and then I see how much distance they have.
Yeah, so now you have all the x's. So you have to take all that consideration. So one idea is So taking supremum of all such x's, okay? So here it is, instead of it is discrete distribution. So here it will look like this. Here it will look like this. Here, let's say you're taking over 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's say these are the ones. Okay, in another case, it's like this. Okay, I'm not sure whether it's like the sum will be the same or not, but yeah, I mean, I'm just giving an idea. In another case, it's like this. You can just understand that the blue function is actually close to the white function. It's like behaving the same. Okay. So that's also an idea, but when it will get closer and closer, the curve will be the same. In that sense, what we are understanding is that in what sense the distance between is this to our, how can we define a distance between this to discrete distribution? So what we are telling is that here, it's a homework, but here let's come here. So what you're telling is that for each one of them, I calculate the individual distance of probability. And we sum it, take a modulus of it and sum it divided by 2. Okay. This is one of the distance notion. So let's take an example. So here, let's take Bernoulli. So for Bernoulli 0, 1, Bernoulli P and Bernoulli Q, let's say. So Bernoulli P and Bernoulli Q का distance क्या होगा? Let this be P1. Let this be P2. ठीक है, इसका distance क्या होगा? बोलो. So distance of P1, P2 क्या होगा? It's summation of what? P of 1, P2 of n by 2. Did you understand the idea, Mihika?
Yes, sir.
Yeah. So this is the basic idea. We are trying to understand. How to probability distributions really close to each other. This is the main understanding, guys. Okay. And we need to define it mathematically. So there is something other notion of distance. So when can something by distance? It must follow triangle inequality. Okay. But I'm not going into that because I mean that will be too technical. We will not get a sense. You have to show that d of P1, P2 is equal to 0 if and only if P1 is equal to P2. Okay. Also, you have to show that d of P1, P1 is equal to 0. These are the two conditions that we need to show. Triangle inequality follows from the modulus property. Okay. This is always very true because if this is the summation of modulus is, so if it's very easy to understand that if summation of modulus of xi is equal to 0, that implies that xi are 0 because all of these are non-negative numbers. Just like if summation of squares are 0, then the each individual of them are 0. Similarly here, if summation of modulus of xi is 0, individual xi is 0. That means it comes over here. That is P1 must be equal to P2. P1 n equal to must be P2 n. And similarly, you can do it like this. So these are very easy conditions. I will not go into this, but let's understand. Let's apply this. Okay, let's apply this concept over here. So in fact, this is the distance. Okay. So if we define like this, guys, if we define like this, so what we will get? Tell me the distance between two Bernoulli, P and Q. Bolo.
Sir, it can be P minus Q mod plus 1 minus P minus 1 minus Q mod divided by 2.
Okay, so you understand P1 and P1 and P2 are 0 for other than 1 and 0. So the idea is half is common. So what you get over here is this. P minus Q for the one part, okay? Plus, it's a modulus, plus 1 minus P minus 1 minus Q. So can you tell me what do you get finally? Can someone tell me? What do you get finally for this? So trying to understand this. 0, 0? P and Q are not, P and is not equal to Q.
Oh, but 1 minus of minus 1 will cancel out each other, right?
Yeah, so what will that be?
And oh, sorry, that will be P minus Q. Sorry, mod of P minus Q. I'm so sorry.
Yes, mod of P minus Q, right? So it makes sense. So you understand Now, if P and Q are close, they two boundary will behave close. So let me show you the diagram. Now, can you tell me what can be the maximum value of this? Maximum value. Tell me the maximum value of this. Max. That means 1. When it will happen? When will D of P1, P2 be max? So why I'm saying if 1 is 0, like if P is equal to 1, Q is equal to 0, or Q is equal to 1, P is equal to 0. That means what? They're exactly opposite of each other, right? You see, therefore the distance is maximum when they're exactly opposite of each other. Does it make sense now? That it is actually defining a distance, guys. So this is the idea. So also you can understand if P is equal to Q, then the distance of these two must be equal. That is two Bernoulli distances are equal. So let's I will not discuss any special random variables because I have not taught my class binomial and some other things, but I will define random variables and their discrete distributions, and we'll check it's actually a PMF, valid PMF. Okay, so we just need to check its summation of pi is 1. That's a valid PMF. Did not do what is a binomial and Poisson. We don't. If you know it, it's good. If you not, then we will learn it soon. But we will just define random variables, understand that actually what is the distance between them. So what we are doing. So let's do it for some other random variable. Let's take x1 binomial, but I will not tell what is a binomial. Okay, let's do it like this. Let's take two random variables like x follows binomial n comma p. So if you know this is good, if you not, the definition of the random variable is this: that probability x takes values, every x takes values in 0, 1 to n, and probability of x is equal to I is equal to n choose I p to the power I into 1 minus p to the power I, n minus I. So let's check whether it's a valid distribution or not. It's a very simple binomial theorem example, that summation of pi I from 1 to n, 0 from 1 to n is equal to summation of I from 0 to n choose I p to the power I into 1 minus p whole to the power n minus I, and we'll get what? We'll get p plus 1 minus p. This is x. This is what? This is x plus y whole to the power n ka expansion, right? I hope you know this because you must be reading this in your 11th, 12th. Okay, if you have not, then please revise your high school mathematics part. This is the idea, and this is equal to 1. So this is what the the thing is. If you don't know this, go back and revise the combinatorics part. Okay, we have done the combinatorics part in our previous class. We have discussed this, why this is equal to this. So revise that if you don't know that. It's on our recordings. Okay, it's like for our internal students. So okay, perfect. So this is the basic idea, and yeah, and it's a valid distribution. So let's calculate the binomial p comma q के लिए अभी क्या होगा. So let's check p1 is equal to binomial n comma p, and let's check p2 is equal to binomial n comma q. Now let's calculate the distance between p1 and p2. Calculate it, guys. Calculate it in front of me now. Calculate the distance between p and q now, and we'll see when are these two totally different behaving. When do you expect it to be totally different, guys? Tell me. When do you expect it to be totally different? When do you expect it to be totally different? Any ideas? Yeah, which one will I repeat?
Ma'am, sir, I'm sorry, I can't hear you, sir.
Okay, all of you, none of you can hear me? Or is it? Oh, I think it's Tanvir's audible problem, like audio problem.
No, I'm sorry. I mean, I couldn't hear the question. Like when you said it.
Oh, I told that x follows binomial n comma p, and y follows. No, x follows binomial n comma p. I just told that it's really a valid distribution. Okay, did you understand this part, Tanvir? It's like a valid random variable, discrete random variable. Did you understand this part?
Yes.
Okay, so my question is now that if we take two binomial n comma p and n comma q, what is the distance between this two binomial? Calculate it and understand when the distance will be minimum or maximum. You know, minimum will be at 0, but we will understand in terms of P and Q. P1 like P and Q actually. And also I will tell you something. It's symmetric. You see, if you just replace this with symmetric. Anyways, let's calculate this. Let's calculate this. Since we have less time, let's calculate this. It's summation of I from 0 to n P1 of I minus P2 of I whole modulus, and it's equal to summation of I from 0 to n. What will you get? In choose I P to the power I into 1 minus P whole to the power r n minus I minus n choose I Q to the power I into 1 minus Q whole to the power n minus I. Perfect. Let's calculate this. To get n choose I common out.
Divide by 2.
Oh yeah, half is there. Yes. So I will tell you where this will be required. You will be requiring this to actually test, when we have data. Na? So one of the first aim is to understand, maybe people are learning this, that whether a data fits a distribution or not. Okay. That's the main idea. Whether of data is actually, some days back one person was asking whether this data gives you an idea whether it's a normal distribution or not. So you have a discrete data or a histogram and you're asking whether it's a normal distribution or not. So, or maybe you have discrete data, you're understanding whether you have a data and you're asking, you have various random variables, okay? You have a data, okay? And the data may what you got 1 to be 5 by, let's say you have got data and data may you have got 0, 1, 2, 3. Okay, इसमें you have got 0.35, 0.1, 0.2, 0.2. This is what you have got. And you have lots and lots of random variables you must be knowing after some days. Okay. So my question is that whether you want to fit a common distribution to it. Let's say you want to fit a Poisson or a Bernoulli or a binomial or kuch bhi. So you want to find a distance. For that, you know this P1, P2, P0, P1, P2. You know that values. Okay. So if you understand whether this data actually matches this or not. You understand the idea, guys. You understand the idea. I will do this exercise with you on Monday with the real data. And this is the idea that given a data, how can you understand that these two are actually close to each other? These two functions are actually close to each other. This is the basic idea. Okay. This is a basic thing you must know to make it much more like this is a basic idea in statistics that whether a discrete data actually fits a real data scene. And we will use this idea only. You will learn, maybe not in our class, but even in your college, and you will do non-parametric estimation, or in your master's, wherever you go in non-parametric estimation, you will see that this distance is coming out to be really important stuff. Okay, so this is an idea that you understood that how it's related to data, right? Did you understand how it's related to data? Did you understand this, guys? Boom. Yes, right, boom. Good. If you understand like this, good. Perfect. Good. This is really interesting. And let's understand what else we can do with this. So let's calculate this. So that's why many times it will not be really feasible for you to write. Okay. This that's why we need computer algorithms to compute this. But let's see if we can write this up in choose I. So that's why many people learn Kullback-Leibov's distance and many other divergence and distances are there. Okay. When you will learn machine learning and stuff in your future, you will see that these things will come out to be really, really important. Okay. This will really, really come out to be important in your life, understanding probability distributions. And yeah, so this is really important. So it's p to the power I into 1 minus p whole to the power n minus I minus q to the power I into 1 minus q whole to the power n minus I. I don't think there's a good way of getting through this. I don't see anything. I don't really see anything. Okay, but we can plot it. Fixing q, we can plot it. Okay, fixing q, we can plot it. I don't know if I have time to do that now. But let's not do that. Okay, let's not do that. Let's try to do this for some known distributions. So you know already binomial. Okay, let's calculate it for something else. So we'll do Poisson binomial now. So we have done that We have no what is binomial. I will revise that, but let's not go into binomial now. Let's go into this. Let's go in just with the definition, okay? N comma P with the corresponding PIs I have defined above. P0, P1 dot Pn. And we have P2, that is Poisson, let's say. So let's not take N and P, let's take this. Let's take 3 comma 1 by 3. Okay, let's take real examples. You see, it's becoming hard for that part. So what we'll do, we will take real examples. Binomial 3 comma 1 by 3 and Poisson 1. We'll understand the relationship between this. Okay, so binomial 1 comma is 0, 1, 2, 3. इसके लिए what turns out? I think it's what is the value? Can you just tell me what is the value? It's 1 by 3 whole to the power 3, I guess. Yes, it's 3 times. Can you just quickly tell me the value, guys? 1 by 3 into 3 square into 2 by 3. And here 3 into 1 by 3 into 2 by 3 whole cube whole square is 4 by 3 square, and here it's 3 into 1 by 3 into 2 by 3 whole cube. So we have,
Where the first value should be 2 by 3 to the power 3.
this one.
Yeah.
2. Oh yeah, you're right, I have done mistakes. Yes, that is, it will be 8 by 9, 8 by 27. Okay,
Yeah.
I'm just calculating real values. What is this? Can you tell me? It's 3 into 1 by 3 into 2 by 3 whole square. That is 4 by 9, right? Here also it will be 4 by 9, I guess. Oh no, it is not symmetric. 3 into 1 by 3 whole square. That is 1 by 3 into 2 by 3. That is 2 by 9.
Hello.
2 by 9. And here it will be 1 by 27, right? Am I right, guys? Am I correct in calculations? Am I correct in calculations? Is I'm doing anything wrong? Is it fine? So let's, huh? Hello? Yeah. Okay, perfect. Yeah, it's good to, it's good to tell me via voice, because I have to again go to Google Map to check the chat list. It wastes time of the class. Okay, so sum is equal to 1. But see, Poisson is defined for 0, 1, 2, all the, like, I will define another one, that is, this is how it's defined. It's e to the power probability x is equal to I is equal to e to the power minus lambda to the power I by I factorial. So what we will do, we will do e to the power minus 1 here into y. It's a random variable, y it's a discrete distribution function. Let's do it. E to the power minus lambda to the power I by I factorial. If you do this, you will get that it's e to the power minus lambda into summation of lambda to the power I by I factorial, I from 0 to infinity. This is equal to e to the power lambda by Taylor series expansion. So e to the power minus lambda into e to the power lambda is equal to 1. So you know it. So here it's e to the power minus 1. Here e to the power minus 1 into lambda is 1 by I factorial, by 1 factorial. Here it is e to the power minus 1 by 2 factorial. Here it is minus 1 by 3 factorial, and it continues. So let's calculate the distance, guys. So distance between P1 and P2 is therefore what? So understand, for all of these numbers greater than 3, binomial will be 0. So sum half into summation of n is equal to 0 to infinity, P1 this minus P2 this. So you get half into, let's calculate the initial ones. 8 by 27 minus e to the power minus 1 plus 4 by 9 minus e to the power minus 1 by 1 factorial. plus 2 by 9.
But sir,
Yeah, bolo.
but why are we calculating Poisson with the binomial, sir?
Oh, who is this?
Sir Madhav.
Because we will show that Poisson actually converges towards binomial actually converges towards Poisson. We will show that soon. That binomial n comma p.
Okay, sir. So as like binomial, the trials increases, it converges to Poisson.
Yeah, if n comma p goes to lambda.
Okay.
Yeah, in fact, we can show that actually distance between these two things are actually decreasing as np goes to lambda. We can show this by this. Okay, so this is the idea of distance. Okay, so this is something, as I told, it's not something easily computable by hand. It's something that you can compute it by like computer. That's why it's written in computer and is in statistics. So next here we got 1 by 27 minus e to the power minus 1 by 3 factorial. That is yes. And the rest of the part is plus half into summation of e to the power minus 1 by k factorial, k is greater than or equal to 4. Okay. So can you calculate this stuff, guys? Can you calculate this stuff? Can anyone calculate this stuff by hand? I will give you 2-3 minutes. Why I'm telling you this is that it will give an enhancement of understanding that what is really happening here. No, Madhav, this is not the first class of discrete. Didn't you do the lectures, Madhav?
No, sir.
Huh?
Actually, yes, sir. Actually, you told me to look into probability, sir. So I didn't start this one, sir. This is my first class of discrete.
No, I asked you to show the see the probability lectures in Google Classroom that we have, right?
Yes, sir.
Did you watch those?
Sir, I just started those, sir. I couldn't.
Okay, please focus on those. Okay, otherwise you will get confused in the class. Otherwise, I would have made videos if you don't watch them. It's very important. Okay, please watch into those.
Sir.
Otherwise, you will get lost and you will get demotivated. Okay, that's not good. What I want.
Okay, sir. So now we are doing the distributions.
Discrete random variables. Yeah, and next day
Random variables.
yeah, next day people will start. We will start distribution function of discrete random variables, and I will do on the other hand the examples of the famous random variables or discrete random variables.
Okay,
That is binomial, Poisson, geometric. Those will come really fast. Okay, so yeah, tell me what is the anyone calculating, guys? Anyone calculating? Anyone calculating this value? Mihika, Tanveer, Poulomi, Nasir, Bhushan. Anyone calculating this value? Or you are just waiting for each other to calculate this? Okay. Okay, we can write a program. Okay, you can write a real life program to see whether what is really happening. Do you want me to do the program now? I can do that if you want.
Yes, sir. Not Python, please.
No Python. I will use R.
Yes, sir. Yes, sir. Okay.
Do you want me to do it now and show it to you?
Okay. Sure.
Okay, fine.
So,
Okay. Okay, so let me do that. I will share my screen. Okay, so R kahan gaya? Yes, so R is on. Okay, so can you see my R screen? Last day I've seen is shown you the moments, right? I hope you remember that.
Yes, sir.
Yes, so let's do it now. So we will find the distance between binomial 3, 1 by 3 and Poisson what? Poisson 1, right? The good thing is that we have the probabilities. So how do you find the probabilities? B binom बोल के search करो, you will find the probabilities. You will find all these things. See, it tells you that if you look into this here, it tells you that d binom x gives what? D binom x gives the value, the density. Okay, that is in case of I mean not density over here. It actually gives you the corresponding values of the random variable, like values, the probability values. So, want to see an example? D binom of size x is equal to. Am I doing it correctly? Just give me a minute. Yes, d binom of x. Say x is equal to which x value? Okay, let's say 1, and size is n. Okay, size is the n, binomial n comma p. So here is 3 and there is 1 by 3. Okay, and it's 0.44. So what was the probability? Is that what was the probability of 0? It was 8 by 27, right? Oh, did I do some mistakes? Oh, it was 0. So it was, let me just go back. It was 4 by 9. Let's check. It's 4 by 9. No, not 4 by 9. It's 4 by 9. So you can see it's 4 by 9. Did you understand this, guys, all of you? What I did over here in R? We did that the binom gives a probability of binomial of x is equal to the first one for binomial. Can you see my screen, guys? 3 comma 1 by 3. Can you see my screen?
Yes,
good.
Yes,
Okay, all of you understood this? Please please, like, I cannot really go back to the screen and say yes on, like, see your replies.
Yes.
Okay, all of you understand it, right? So therefore d binomial gives the set of all probabilities, right? So let's find out the set of all probabilities for a vector. Okay, that means what is a vector over here? What is the support? Like, not the support. Support means where it's defined, the density, the probability distribution is defined. So here the support is we can call the support is same. Support is same. Let's not take it for a very large n. Okay, let's not take it for a very large n. Okay, so Poisson after some time it will be really large. So let's do it till 100. Okay, let's do it till 100. So let's similarly do it for d Poisson. If you want to understand d Poisson, you can see over here x lambda. So d Poisson here, if you do d Poisson of x, that is x is equal to 100 comma 1, you will see it's very e to the power minus 159. This is very less. So if you sum it up, it will not really matter. Okay, that's why we will define the support till 100. That is, we will define a sequence from 1, or you can just do it like 0 to 100. It's a sequence of 0 to 100. So let's check it how it looks like. You see 0, 1, 2, 3, 100. Okay, that is the idea. And similarly, what we'll do, we will define the Poisson binomial. Binomial is what? Is actually d Poisson. Okay, let's first check whether binomial is defined here or not. On x is equal to 100. I hope it gives 0. Please give me 0. Otherwise, I have to again write an algorithm for that. The binomial 100 comma 3 comma 1 by 3. Yeah, it's giving me that. Thanks God. Good. So therefore, d binom of support, we're getting all the vector values, and 3 comma 1 by 3. I will tell you what I'm doing over here because I need the next. Okay, so okay, let's not do that. Okay, binomial, we have got it. Let's check it out. Binomial, how it looks like. It's a set of probabilities, okay? The probabilities that we know. Okay. Did you understand, all of you? What is this giving, guys? All of you say yes or no.
Yes, sir.
All of you understood this? Any doubts, guys? Any doubts?
No, sir.
Okay, perfect. So therefore, we are getting the binomial ka PMF till 100. Similarly, we'll do the Poisson ka PMF till 100. Okay, it's not sum is equal to 1, okay, but understand that we are doing it because we cannot do it till infinity. That's why we need to do it till 100. Okay, so for Poisson, it's support and lambda is equal to 1. Okay, it's with Poisson. Let's check it. See, now you see it, all of you see it, guys. This is a Poisson ka support. Okay, now we'll calculate the distance between them. Distance is equal to, how will you do it? It's very simple. How will you define it? Simple. What is that definition? It's summation of, take the modulus of it, right? So absolute value of the two. The beautiful thing is that everything is in terms of vectors, so you can define it like this. It's the absolute value of the vector format. Okay. No, there is something different. Oh, I think I need to define it like that. So D binomial. Yeah. Oh, yeah. I will get that absolute value of this. I hope I get this. We'll get all the absolute values. Okay. It's not a distance. Let's check it out. What this gives. This gives all the positive values of that. Okay. All the positive values. The distance between that. This is giving the P1 of I minus like P1. This is P1 of 1 minus P2 of 1, uska modulus. This is P1 of 1 minus P2 of 1, P1 of 2, P2 of 2, uska modulus, minus ka. Similarly, it's giving this. All of you understood what this is giving, guys? And it is not a distance yet. This one, did you understand, all of you?
Yes, sir. Yes, sir.
Sub, did you understand?
Yes, sir.
Good. So now we'll do a sum on it. Okay. Times 0.5. This is the distance. So let's check the distance. Distance is turning out to be 0.114. Okay. So this distance is coming out to 0.114. Now tell me, what is the next step I should do since I have got this function now? What is the next step I should do? I should increase n and p, keeping np is equal to 1. Okay. Let's see. We will keep np is equal to 1. And we'll create, let's take to be 4, 1 by 4. And let's check the distance once again. It's decreasing, you see? And if you increase it, let's take 5, 1 by 5. You will again see it's decreasing. It's 0.06. It's decreasing slowly, but it's decreasing. Did you understand, guys? And if you take it to be, let's say 99.99, let's check the distance. It's very small. That means they are going close towards each other, binomial and Poisson. Okay. So we can do it. We can do different binomials too. Okay. Let's plot it. Let's plot it. Let's try to do it. Let's try to plot it. How we will plot it? Let's say. Let's say what I will do is that I will make a distance function. So what I'm doing, I'm just explaining it to you. So I'm going to run a loop. Okay. If you're preparing for CMI Data Science, this will help you for understanding the loop structure. So I'm just running a loop. Okay. What I will do, why I'm doing is because I want to get a sequence of distance or like this to show that it's actually decreasing as n and p is increasing. Okay. That is the aim. The aim is to show that as n increases, p decreases for binomial and np is equal to 1, binomial and Poisson are going close to each other. This is the basic idea. That means the distance is becoming closer to 0. So for this, I need to define this. So this is n actually, not 1 into this. So what I will do is that we need to first denote this binomial. It's n comma 1 by n it will be then. Okay. So we are doing a loop on n. Okay, I understood. We are increasing n step by step. P is equal to 1 by n over here. We're assuming that, so that np is equal to 1. And similarly, Poisson will remaining the same always. And now we define the distance. The distance is defined like this. Okay. Now we will add another value, that is d. That is the sequence of distance d is equal to null. That is, it's not taking any value initially, but as it goes on, it will start taking values. That is, we will do like this: d is equal to c comma, so c comma b comma distance. What it's doing is that this means it's appending. Like here, if you do v, okay, let's clear it. If you take v is equal to 1 and you take w is equal to c of v comma 2, what will happen is that it's concurrent. Okay, it's concurrent 1 and 2 together. Similarly, what we are doing, since we are wanting to find an array, a vector of such, we are merging this together, okay, to make a sequence, because we want a sequence, an array, a vector of numbers. So that's why I'm concatenating the previous distance ka value, previous vector of distances that we already have with a new distance. Okay, and we want to see this d finally. Okay, let's do this and let's check it out. So we'll see the d now. D is this sequence. So instead of doing this, let's plot d. Plot 1 to 1000, comma, oops. You see this value? It's actually very decreasing. Okay, I think I have to do it. Yeah. Can you see this, guys? Can you see this diagram? It's very far, and then as it goes, it's going towards 0. Do you see it, guys? Say yes or no. Write a boom in the comments if you like it.
Yes, sir. Yes, sir.
So this is actually decreasing slowly. Not slowly, actually, it's decreasing very fast, very going close towards 0. Okay, that means it's really behaving very close, like very closely towards that, like how it's like very closer towards Poisson. That is, binomial is going towards this. If you know the binomial, it's okay. You know the support of this. You know the random variables of this. We understand now mathematically why this happens. Why np as n goes increases and p is 1 by n, np goes to 1, then this is actually decreasing the distance. Okay, did you like it, guys? Did you like it? Yep. Did you enjoy it? Good. Thank you for the booms. Okay, so let's now do the math part of it. And I will end the class with the math part. And next I will give you the explanation of binomial and what is the real life meaning. But let's do the math part. Okay, I'll share the screen now. Do the math part now. Okay, so okay, by the way, guys who are online, if you have not subscribed to our channel, do subscribe. Okay, and yep, and also like we are giving free like diagnostic tests for IIT JAM, CMI Data Science, and ISI MStat. Do check out in our website. It's given in the description below. So yep, it's a diagnostic test, and you can give it and understand your progress. Okay, all the best for that. Yep, and if you have not subscribed, please do subscribe to our channel. Okay, perfect. So let's come back to this. So understand that. So what we need to show is that probability x is equal to I was what? N choose I, p to the power I into 1 minus p to the power n minus I. This must go towards what? The Poisson probability, that is e to the power minus lambda. What is lambda? Np is equal to goes to lambda. Okay, np goes to lambda. Remember this. This is the definition. Np goes to lambda. As n increases and p decreases, np goes to lambda. So therefore, we need to find this in terms of n and p. Okay, that's the beautiful idea. E to the power minus lambda, lambda to the power I by I factorial. This is what you need to show as np goes to lambda. This is a sequence problem, limit problem of real analysis problem. That's how probability and real analysis comes together in terms of sequence, convergence of probability, convergence of distribution, and stuff like this. So let's prove it, guys. It's very easy. So let's expand this n choose 1, n choose I. That is n into n minus 1 into n minus 2 dot n minus I plus 1 by 1, 2, 3 dot I. Is it fine? I think so. It is fine. If I'm doing some mistake, it's we don't need I factorial because I factorial is already here. Okay, so below is I factorial. It's already there. So we need I factorial. It's p to the power I. You see, I don't remember the proof. I don't remember the steps. I am just doing it normally. Okay, so this is the idea. We need to show this goes to e to the power minus lambda, lambda to the power I by I factor. Understand how I am thinking. Okay. Understand how I am thinking. So you need to use this limit. So you have to engage, you have to make this in terms of NP, a function of NP only. Okay. How to do that? That's the first step. Otherwise, we will not get to this. So I factorial is already there. So let's not focus on I factorial. You need to prove this that n minus 1, n minus 2, n minus I plus 1 into p to the power I into 1 minus p to the power n minus I goes towards e to the power minus lambda, lambda to the power I as np goes to lambda. So what is this? So here I terms over here need to do np. So what we need to, what we can do? Any ideas, guys, what we can do? So we need to go np towards lambda. So we need something like this. np plus some epsilon go whole to the power I into something else. So we can do like this. I don't know. Let's check it out. What we can do? We need np. Okay. And how many terms over here? We can have on n from here.
There are I terms, right?
There are I terms.
For n.
Okay, there are I
P
terms.
is the power, so we can distribute the P also.
Okay, we can distribute the P. Okay, sounds good. Okay, so we are telling that we want np by, okay, so np to the power lambda into e to the power minus lambda. So we need to have a e to the power minus lambda too. So therefore, e to the power minus lambda looks like what? What does e to the power minus x look like, guys? Do you remember?
What's that? Can you please repeat?
What does e to the power minus x minus lambda looks like? Where is this coming from? That's my question to you. So I'm giving you step by step how to. This is a step where people will get stuck. So what you will do now? NP. So Tanvi is telling that let's do this. Let's do NP into, like, distribute P among this. Is it a good idea? That's what I'm asking to you. Is it a good idea? Not. How to do this? That's my question is to you.
So we can also see it like this, that we can make pairs of NP into 1 minus P. Like all the pairs we can make like that, right?
Yeah.
And then we can see that if we're making such pairs, then what pattern it is following, it's like NP into 1 minus NP into 1 minus P, the whole raised to 1, like the whole raised, it, like they are following their own.
Yeah, you're right. Go ahead.
I think they're following a Bernoulli process, like something like that.
No,
Like
don't throw terms. No. Don't throw terms away like that. So do you remember, like, do you know a limit jiska goes to e to the power x or something like? Do you know such a limit? How does that limit look like?
Yes.
What is that?
1 plus x by n to the power n.
Can you apply
Yes.
that over here somehow?
Yes.
Yes, we can.
That is one idea. Okay, so that should first come to your mind. Another is that NP is going towards lambda. So how do you apply this? Tell me. Without seeing the solution or something like that, like just tell me, how does it look like? So you must have something like this: one e to the power minus lambda. It should be like this: e to the power minus lambda. So rather it should be e to the power minus lambda NP by n whole to the power n. Okay.
So we can take n out common from all these terms.
Okay, that's really good. That's really good. Oops, I just did a lot of undos. Anyways, so he is telling that who is this? What is the name?
Mother.
Yeah, Madhav is right. So let's take n to the power, like, let's take n to the power something common. Okay, so we have n p to the power here. So that's a really good idea. So we want a p to the np to the power I. So we take n common from each one of them. So you get 1 into 1 minus 1 by n into 1 minus 2 by n dot into 1 minus I plus 1 by n. ठीक है? Into 1 minus p whole to the power n minus I. So we have got the secret for lambda to the power I. Now what is the secret for e to the power minus lambda? Yeah, bolo abhi. It's going interesting.
In place of 1 minus p, we can write now 1 minus np by n.
Okay, lovely, good. So this is really intelligent. So np by n, as I told, that you need to show 1 plus x whole to the power n. This goes to e to the power x. So if you want to show e to the power minus lambda, it goes to 1 minus lambda by n whole to the power n. And lambda is equal to np. So it's like 1 minus p. This is the idea. That's why I actually cleared it out. If you just see it, it's np by n whole to the power n whole to the power e to the power minus lambda. So it's like 1 minus p whole to the power n in some sense. So here it's 1 minus p whole to the n minus I. I is fixed. This is a beautiful part. So it doesn't matter. So yeah, perfect. So 1 minus np whole to the n minus I. Lovely. And what will this happen to this? It's really easy. Bolo, what will happen to this weird term?
1.
Why?
Because when n will tends to...
Oh, you are Sneha, right?
Yes.
No, don't tell to your juniors. Junior na bolo.
Okay.
Juniors bolo. All the juniors over here. Madhav, Mayur, Mihika, Palash, Nasir, Polomi, Priyanks, Tanveer. Bolo juniors. Your seniors gave you most of the ideas, guys.
When n tends to become the large,
Yeah, Polomi.
become 0.
Yeah, bolo. Again, Polomi.
Then when n tends to very large, means large value when it will take, then 1 by n, 2 by n, that part will become 0, and that's why that part...
But there are a lot of numbers over here. So, will it happen for all of the product?
Yeah, that 1 minus 1 by n part will become 1. Next part will become 1.
What if
again.
n is very? What if I is very large? What if I is very large? You understand, Polomi? The problem. What if I is very large? Let's say 1 lakh. For n, n is actually huge. N is going to be with infinity, so 1 lakh is possible. What if I is very large? Tell me. What if I is very large?
So that won't matter, right? Because
Yeah.
like if I'm given only that limit, I can consider the constant out, and 1 by n will always tend to infinity, and the whole term will tend to infinity.
No, you're not getting the point.
Sorry, 1 by n will tend to infinity, and 1 by n will always tend to 0.
Yeah, but my question is that what if I is very large? Like, I want a simple answer from you. Like, the answer is very simple, okay? But I want that term from you. what we are trying to show here and why it will. So what if I is very large? That's my question to you. This will go to
Still
0.
it will be 0. Like I plus 1 by n will still be 0 if I is very large.
Yeah, so what does it mean? Like, you know, I is very large, like you can do like this. There's a result. You can do like this. Like, you can understand that here only. I mean, we can do like this. NP minus NP by n. This doesn't go to 0, right? This does not go to 0. This does not go to 1. It goes to 1 minus p, right? NP by n goes to 1 minus p. So what if I is very large? That's my question to you. Do you understand? 1 minus np by n does not go to 0, 0 or 1. It goes to 1 minus p. You understand the problem, Mihika? I want to see it. So there is something, some other different argument, not what you're telling. Like you're telling right, but there is something, one extra step that you must miss. And if you stop, don't write this in PSA, you will get your marks deducted because these are very core concepts. Anyone? It's very easy. Sneha, bolo. Show your seniorness.
So it goes to 1 minus p, but for that p will be very small now.
For that,
P will be like very small.
no. Let me show you this. In 0.5 n, like 1 minus n by 2 by n, as n tends to infinity, this goes to half. Because on n gets cancelled 1 by half. So what if I is very large? You see, this is true, very true. I can easily show it. Like it's very.
So if the I is very large, then it will not lead to. It will not lead to 0, I guess.
Yeah, then the inequality, then the result is false. It must go to 1, but why?
Yeah. So the reason for that is because the whole limit will converge to. Firstly, it will not go to 0. I'm sure about it. Okay. Secondly, I guess the thing is, this whole is just. I'm just to give me a minute. I know what I'm talking about. Just a minute.
Yeah, this is the thing. I mean, this is really intuitive, but it's not coming. It's in Bengal. It's called PTS. It's coming to gut, but not coming to the mouth. Not expressing oneself. Okay, I will share. It's very easy.
1 minus that thing to the power, it is not a function of n. That is why it will go to 1.
Perfect. So here, the idea is that here, I is a fixed. It's a constant. We are showing that probability of x is equal to I in binomial goes to probability of x is equal to I in Poisson. I is a constant. It doesn't matter what I is actually. I is just a constant. So you must keep this in your mind what you're doing, okay? So that's why we can do it. There are finitely many of them, okay? There cannot be infinitely many of them because I is a finite quantity, always. So I is not infinite. So therefore, 1 minus k by n always go to 1 for each one of them. So it goes to 1. Okay, all of you understood the idea now? The proof, this goes to lambda to the power I now. This goes to 1 and this goes to e to the power minus lambda. Did you understand, guys? All of you understood it? Going to tell me the solution? Yeah? Okay, perfect. Tanvi, did you understand? Mayur, Madhav. Okay, perfect. Yeah. So this is a basic idea, guys. This is a basic idea, and I will end the class here. There's nothing more to do. Do you have some doubts in here? Tell me. Do you have some doubts in here? So your homework is the following. Your homework is to understand this proof, why this is true. Remember your homework. I will share it in WhatsApp also. ठीक है? Okay, guys. Good night, guys, and have a beautiful day. Beautiful night on this full moon day, and I will see you in the next class. Bye bye. Any questions? Any doubts? Otherwise, my pleasure. My pleasure. I hope you learned something new. And yeah, to the online live people, if you have not subscribed, please subscribe to our channel and share the videos that we do to your friends to help them learn during this hard time.